Okay, for the recording, what we're going to be doing is we're going to be talking about, we're going to start off with the joins, and then the big plan is to go from the joins through to single row functions, group functions, and then analytic functions, all of which can be found in the single and group functions area. All right, so what I was talking about here is that if I wanted to get a single query that somehow managed to pull the authors of customers, I can't go directly. I have to basically go through this path. And so I started basically by saying that here's the author, the primary key. Oh, the other thing that was a key point was that with the SQL statement, start with the from. From is your engine where the data is coming from. The select is merely what you want to see. So in this case, the author, I'm going to go from, I could have chosen, by the way, to go from customer through to author. For whatever reason, I chose to go from author through to customer. So I'm going author to a book author. So we get the primary key of one, going to the foreign key of the other. I then go from books to book author, right? Primary key of B to the foreign key of BA. I asked what kind of table this was, and I love it, man. Oh my goodness, 2 answers came back. If someone can come up with a third, we will just end the class right now. We're not really going to, but let's see. So we have the intersection table in the chat. We have cross-reference, or even XREF, sometimes they're called. All right, well, the final one is the associative table. That's the other name for this thing, because this thing associates books with author, book author. And it's not a bad practice sometimes for people to make the associative tables the combination of the 2 names. Understand, though, that you only have 30 characters to choose from for an object name. So if your table, like these tables have got ridiculously short names. I've never seen tables with short names like this out in the real world, right? So sometimes they get a little bit longer, and so sometimes you just can't do that. But if there's some way to kind of indicate that this guy here is associating these 2, either by the name of the table or also by putting it in the comments of that table, that's a good deal. All right, so now we're these 3 things, author, book author, and books are all connected. Next step is we now, at least we can answer with some definity what books each author wrote, right? So we got that. Now to get to the customers, we're going to go up to order items. Order items is another associative cross-reference intersection table. So again, what you're seeing here with book order items is you see there's the primary key and there's the foreign key, OI, for order items. Then over here for orders, we're going to see orders going from the primary key to the foreign key. It's not the way I would have liked it, left to right, right to left, but it doesn't matter. The point is those are the keys. Cool. And then at this point now we know what orders the authors are on, and then finally we make this final jump, right? So this is not an associative table. This is just basically a child table of customers. The other concept that I've been trying to kind of drill home, and may as well focus on it as we're recording, is remember customers would be considered a primary entity because the customer exists outside of the database. Author would also be considered a primary entity, as publisher would be, right? These 3 would definitely be primary entities. You could argue maybe even the book would be. Then you get these things like, what's an order? An order really only has its context inside this database. So that would be a secondary entity. And then we have our 2 cross-reference or associative entities. So that's how that goes. All right, so that's basically a quick little review. We did this whole thing using inner joins. This means that in order to show up on this report, the customer would have had to have a book, and that book would have had to have been written by an author. So I'm not capturing books that were not bought by any customers, and I'm not capturing any customers that didn't buy any books. All that's because these are all inner joins, and I'll remind you that inner is, although it's a keyword, it's the default, right? So a lot of times we don't actually see inner pop up, but sometimes you do see it in computer-generated SQL. All right, so where we're going to now is this idea. This select clause is pretty pure. It is basically producing the data exactly as it is in the database with the exact same column names. We've already kind of done, I think previously, earlier this course a few things like maybe putting the last name and the first name together. I think we did that once. So I'm going to go, and that was using a concatenate, right? Concatenate with a literal, and then a concatenate again. And now what I got is I've got myself the first name comma last name, right? I don't think there's really anything else here I'd want to sort of play with. So we're going to start doing some functions first, some functions. So what I want to do is I'm going to basically start with the slides for this, and then try to expand on it as we go. So let's do that. Let's do that. Here we go. Nice. Bang. All right. Cool. All right. So we're going to talk. It's talking here. It's going to say about single row functions, but this actually gives a general rule about all functions first, and then what types of functions there are, and then goes into single row functions. Last week, I said to you guys that going through the single row functions is a lot like going down the spice rack in a grocery store. I mean, there's a lot of them. And some of you might be going, well, when would I use garlic powder? When would I use onion powder? What is the point of time? Right. So, and I understand that what's really important to me out of this whole thing is that you understand some of the meta behind functions, because you got some of this function training too, by the way, in the previous, in the prereq to this as well. So, all right. So we're going to talk about some functions. Let me just go straight to the functions. All right. So a function, right? It's basically a program that's written inside of the database. And the key with a function, which doesn't say here, but I'll just tell you, the key with a function is that a function always has to return something. A function's always spitting something out. You've seen this with your work with sysdate. Sysdate is a function, and what does that function do? It returns today's date. Right? User is another function. And what does that function do? It returns the user. A function always returns something. But now we're going to talk about some functions that actually bring things in. Okay, that's what we're doing now. We're going to look at single rows, which return one row of results for each row, which, if I'm assuming you guys have some prowess with Excel, but in Excel, right, you can put like an upper function. You put it on every, you put it in the cell, and it would repeat for every single row, right? That calculation would happen for every single row. Most of you, this won't be that exciting. But when we talk about multiple row, that's where it becomes really interesting, and that's where we get group and we get analytic functions out of that. So when we talk about single row functions, for sure, you get some case, some basic case conversion, case manipulation, some numeric, date, of which you've already seen sysdate, but there's a few others. Regular expressions, which I'll never, I mean, I'm sure maybe the book will ask you, but that's one of those things that when you're in industry, you might want to look that up, because there's some really neat things you can do with regular expressions. And then some other functions that don't typically fit into anything. I would say that a lot of these are ANSI standard, but now as we're dealing with single row functions, we're going to be deep into Oracle land for some of these as well. I'll try to remind you when we're deep into Oracle land, but like for sure, these other functions, they don't really exist in outside of Oracle, but there's something like them in SQL Server or Postgres or the other relational databases that we're familiar with. Okay, so case conversion function. Case conversion, it alters the case. This is the easiest one, and you can use it in the select and the where. So let's go back to our little book thing here. If I want this to be not in uppercase, but I want it to be in lowercase, I could put this calculation into a lower function. Right, put it into a lower function. I go, it then is converted to lowercase. Great. What can I do to make this column heading a little bit easier on the eyes? Texting or talking. It was a really bad television show at one point. The answer is alias. I could use an alias. And remember, the way we would use an alias is we'd go as, and then I could go full name, for example. right? And now what's going to happen is that this column will change. All right, good deal. So that was from quite a few weeks ago. But anyway, so lower, it takes in a string and it returns a string in lowercase, right? I'm not going to go with this level of detail over the trivial ones as much, but that's an example of a case conversion function. And I think, yeah, so they talk about the lower right away. Notice that this lower here is in the where clause. So for example, Austin, does Austin show up? Austin shows up a couple times. Let's add a where clause here. And I'm going to go where the a dot l name is equal to Austin. Now, this won't work, right? Because Austin's name is actually in uppercase. If I was to say where lower, and I've spelled lower properly, right? This will all of a sudden work, and that's what that slide's trying to show you. Okay, so what these case this is how you kind of make a case insensitive query. You could be saying, hey Grant, come on, this is lowercase, why don't you just type that in uppercase? I will remind you right now about that fabulous concept of the substitution variable. Right, so here's the substitution variable. Now watch what happens when I go run, and off screen it shows me this. If I go Austin, well, now I've typed it the way I know it is in the database, but this doesn't work. So sometimes what we'll see is someone will put a case conversion function on both sides of the equality. So both sides. So now what happens, I go run, and off screen again, thank you. Now I'm going to do it Austin, the way that a human would type it. I'm going to go, and it works, right? So that's making a case insensitive query. That's where you see a lot of these case conversion functions, not necessarily just in how it's presented, but in the where clause, you'll see them as well. And that's kind of what that's saying there. Upper is very much the same thing, just converting it to uppercase. I'm just going to let that stand on its own because I'm sure you're already bored to death with the lower. Let's talk about a knit cap though. Let me show you what the knit cap does. So this is kind of gross, right? It's all lowercase. If I want every initial character capitalized, right? Whoa, why? Oh, no, I thought it was hung for a second. It's not hung. I just have it going off here. I'm going to get rid of that substitution variable in a second. Look at how beautiful that looks. Doesn't that look more beautiful? It sure does, because it's capitalizing the initial letter. Upper and lower are pretty ANSI standard, and knit cap, that word isn't standard. Different databases have a different way to do it, but almost every database I know has a way to capitalize the initial letter with an easy little function like that. So that's what a knit cap is all about. I'm going to keep the where clause around, but I'm going to comment it out so I don't have to deal with that again anymore, right? I don't have to deal with that, right? Notice if it's commented out, it doesn't trigger the substitution variable part. Cool beans. Next. Now let's talk about manipulating characters, right? Manipulating characters. So case conversion, upper, lower, init cap. Now what happens if you want to sort of change some things around? So there's a substring, and I cannot believe the first thing the book shows you is this, which is super gross. So let's go and look at an easier example for this. Let's look at title. Okay, I'm going to actually, I'll play with this one, actually, category. No, title. I'll play with title. All right. So in the past, we've used something called like. Remember that when we basically said select whatever from the database where this is like, and I basically was able to say where it's like, and the first character was an A, and I used a percent and all that, right? What if I only wanted to show the first letter here? I only want to show the first letter here. Maybe there's something significant to that. There's no real barcodes, I don't think, in this data. At least I don't think there is. Is there barcodes in this data? Let's have a look. Barcodes. Books, nope, no barcodes. But imagine that this was like a barcode. There's some kind of intelligence that was sitting inside of that first letter. How would I get only that first letter to show up? I could use a substring. Absolutely an ANSI standard thing. A lot of people will see that there. I go, oh, it's category. Sorry, I want that in the title. Move that over, up. there. Okay, so I want it in the B. So the first thing I got to say, the first input, the first parameter I'm feeding into here is the title. And then typically I'm going to say I'd like it to start and then go for 1. Start and go for 1. So what we're going to see, and with a comma, what we're going to see is the first letter. That's a substring. Great. Now, if I wanted to maybe start on this, start at the first position and go for, let's just say 3, we're going to see the first 3 letters. Cool. If I wanted to start on the second character and go for 3, now we're seeing the next 3 letters, right? And in fact, if I wanted to go crazy and say, hey, I'm going to start like 10 in and go for 3, there you go. Now I'm somewhere over here. So these parameters are, the first thing is what you want, the object that, or the string you want to split. Second thing is where you want to start. Third is how many of the characters. So notice this isn't 10 to 3. This is start at 10, go for 3. Cool. Now let's have a little bit of fun with this. What if I didn't have a third parameter, Grant? What happens then? Well, if you don't have a third parameter, it goes to the end, right? So it just basically starts at the 10th spot and goes straight to the end, no matter how long the end is. Okay. If I wanted to say, hey, why don't we start at, actually, what are they doing here in that slide? They're starting 3 from the back. That's what they're doing there. So I'm going to start 10 from the back. And so now I'm starting at the back and go back 10 characters and then go to the end. I'm not going to explain why you'd ever do it. It's kind of like algebra right now, trying to explain why would you do this, but it's important that you understand that you can split and put things back together. So let's do a kind of a neat one with that email. We're going to make an email out of the author's name because that's actually reasonably easy to do. So I'm going to basically make up myself a new column, and I'm going to remind myself what the a.l name is. L name. Problem when you're writing spreadsheets all day, you lose your typing ability. L name and the a.f name, and do the thing, and we go. So a lot of emails, I know they kind of start with the first letter of the first name and the last, maybe we'll say 8 of the last name. So what we could do here is, first of all, maybe reverse this a little bit. All right. And basically we want the first character of this. So I'm going to go substra, and I'm going to say, please start at the first and go for 1. That's now going to give me a nice little first letter. Then I'm going to basically say I would like this guy to be the last name, but the first 8 characters. You network people should be getting excited about this. So now that's the first 8 characters. So let's get Peterson. No, Peterson. Do we have any long ones? Robinson. Nope. All right, let's make this incredibly unrealistic and make it only 4. We're going to make it 4. Right. So that way you can at least see that we're only getting that. Now I'm going to put them together with a nice little concatenate. Okay, let's do that. I'm going to concatenate that with the domain at dctc.edu. Right, and now I'm going to make the whole thing lowercase. And what that's going to do, let's just go as email, and boom. Right, so I got, that's kind of me making an email out of the existing data. Cool beans. By the way, let's go author email because email is a little generic. All right, so now we got author email, cool beans, and that was an example of a substring. All right, what other thing are we going to show you? The in string. All right, so the in string is basically saying, is something in the string? So if I want to know, for example, is the word database in this string? So let's go with title. I'm going to go in string b.title is the string database in the title. I go, and it says yes. Now, what do you think that number means? Either chat or say it. Gonna make it actually less obvious for, or not not obvious, but what's the word I'm looking for? Some of you might be thinking binary, and I don't want you to think that. So let's do that instead. All right, that should be a little bit more obvious. What is it returning? It's returning the position of that string. So mushroom is appearing in the 14th spot. Okay, it's appearing in the 14th spot. Now I'm using it up here in the select, but it's not hard to imagine. I could say basically where the mushroom in string is greater than 0, that would indicate that mushrooms was in the title. All right. A lot of times what we end up doing as a SQL kind of manipulators, or at least data manipulators, sometimes what we're doing is we're actually looking for a space. Is there a space? And that will kind of indicate that there's more than one word, for example, in here. Or maybe what we want to do is grab the first or the second word even, right? Or grab actually just the first word in the sentence. So first thing we try to do is figure out, well, where is the space? Oh, it's in the 9th spot. Okay. So, okay, what am I going to do, Grant? I'm going to grab only the first word. That's what I'm going to do. So that means that what I want to do is I'm going to go substring B title. I would like you to start at the first bit and end at the space. Now this is going to actually capture something I don't want, but you can't see. It is capturing the space. So if I want to make sure that I don't, because the space appeared on the whatever 9th spot, and that's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've captured that space. What I could do is say, hey, wherever the space is, -1. And although the data is not going to look any different, I know that there's no space on that one. Actually, you know what? You guys are all geeky enough to appreciate this. You're going to say, Grant, how do you know? How do you know? How do you know that you're not just spilling lies out? All right, so here we go. I'm going to show you something really cool, which is not in the book, but you'd want to know. I'm going to show you a nice function called dump. This fits into the category of other, by the way. Dump. Dump actually shows you all the ASCII values of everything in the title. Right? Remember, I'm trying to make you guys like stand out from the chaff. This is one of those things that makes you stand out from the chaff. Dump is showing you every character, its ASCII value, how long it is, like 23. I never figured out what type was. Type might literally be, is it a string or whatever? I don't know, right? I've only used this for characters, right? When I'm trying to figure out what crap is sitting inside of my data, right? So let's look at the dump of these two ideas. And what I'm going to do is put title back the way it was. Okay. And I'm going to grab, okay, so right now we got these two things. You should see, Grant, they look exactly the same. They look the same. How do you know? Well, if we put them both into a dump, we're actually going to see a slight difference between these two. This, by the way, also gets to the concept of nesting, which we're going to talk about right after this. So notice the first one with the -1 is only 8 characters. The second one without the -1 is 9 characters. And what is the last character? 32. So no, I'm not wrong. As usual, I am 100% right. Just kidding. But in this case, that is both a nice demonstration of a pretty neat function and why sometimes when you just want the first word, you want to usually go back a step. All right, cool beans. Let's get dump out of there because that's kind of gross. Let's keep with the right one. Let's get rid of line 5. Get rid of line 5, he says. And way too many parents. So let's pull off some of the parents. Right. So what you're seeing here, though, before I go back to the slides, is you actually are seeing nesting. Right. What happens is we get B title, we get the in string thing that kicks off, and then that itself is used as a value inside of substring. Okay, and so that, oh, actually, let's run it again. Always run your queries, make sure they're working. So there's your example of a nesting function. I don't know what's going on there, so let's let it go. Length is pretty self-explanatory. How long is the address, right? Again, a lot of these are used just for characters. RPAD and LPAD, basically what this is doing is it's taking first name, bringing it out to 12 characters, and whatever it's not like part of that first name, it puts a space on the left-hand side, left pads. They didn't show you right pad, but actually here what they're doing is they're showing you the left pad in asterisks. You know, sometimes, I don't know how many of you even get checks anymore, but checks would actually use this function, right? When you'd see, in fact, actually, let's do this with the money here. Where's the retail? So I'm going to go LPAD, the salary here, or the retail, I should say, and whatever you're not using, use asterisks. There are two things that are going to happen here. First of all, this is numeric. You can tell it's numeric because this is right justified. See how that's right justified? As soon as I do this, two things are happening. It's blowing up. Oh, I didn't want to talk about that yet. Okay, well, you know what? Close your eyes and pretend that you're not seeing this next thing. I will explain it, I promise, but I didn't want to talk about it yet. And it's still invalid because, oh, is there something in there that's not? All right, so I have some data in there that can't convert to a character string. Okay, that's fine. That's fine. That's perfect. Perfect. That's what happens when you try and go off the cuff, Grant. Let me just have a quick peek. Why? It should have been pretty easy. All right, well, you know what? For now, I can't deal with it. So I'm just going to go LPAD, and I'm just going to put 10 as in $10. And I'm going to pad it out to, let's say, 5. And whatever you're not using, do that. And let's see what that does. All right, that was the effect I was looking for. Not sure what's going on in the retail yet, but maybe that'll become obvious later. I don't know. Yeah, I don't know. Anyway, but does that look even vaguely a little bit like the checks? In a minute, I'm going to make it kind of cooler with the characters, the two char, but that's an LPAD, and then RPAD is the opposite. It's putting stuff on the right hand side. Okay, cool. Trim. What trim does is it basically removes PO. It trims PO box. Right there, PO box off the left-hand side. Then R trim would trim it off the right-hand side. Sometimes we use this to remove spaces that are trailing, like spaces that get sucked in with the data. Sometimes, usually, to be honest, I'm using this for data cleansing. So if there's some kind of crappy stuff that pops in the beginning of the string or the end of the string, or even somewhere in the string, there's actually a trim function that will basically pull it from wherever. That's what that's what that is for. Replace is probably obvious too. What it does is, here's the original address, and it replaces PO, that string, with post office. Okay, translate. Okay, so replace, by the way, what that's doing is it's actually literally replacing this string with that string. Translate is it's a titch more involved, and I think actually I'm not going to waste your neural time or my attempt to try and explain it. It's kind of going through and finding multiple occurrences, and it's basically taking every one of these commas and changing it into a dash. Kind of like a replace all, if you want. So here's concat, right? We never use concat because you already know a simpler way to do this, right? All you do is, if you didn't have concat, you just stick the two pipes, and they would put those two strings together. But concat sometimes is used in legacy databases, and so that's why it's kind of a thing. That's why it's brought up. I think also, by the way, concat, I believe, is one of those few ANSI standard ones. So upper, lower, everything's got some kind of trim, and then a replace, I think, is ANSI, and then concat. That was the crazy world of strings and the crazy world of character functions. I think numerical ones will be a little bit easier on our brains, all right, because we're talking about some basic ones: rounding, truncating, and absolute, I think you guys can handle pretty easily. Mod is a little bit weird. So let's talk about the rounds. So here they're taking the retail and they're rounding it to the first decimal spot. And I guess in this case, everything's being rounded up to single integers, okay? Here they're rounding it straight to an integer, and that's a default, by the way. So if you didn't want to put the comma 0, it would round it to the nearest integer. And this is neat, and not many people know about this one, but you can round beyond the integer. So it's actually rounding to the nearest 10. So 31 would round down to 30, 22 would round down to 20, 56 would round up to 60. Pretty neat. A lot of times used with like maybe like seniorities or stuff like that, right? So truncate, what it does is it basically truncates, in this case, the first decimal spot. So the 5 gets lopped off. Notice when it was rounded, it rounded up. Now that it's truncating, you lose your first decimal here. Sorry, you truncate to the first decimal. So the second decimal guys all get cut off, and that's what happens there. So they're truncating to the integer, and then they're truncating all the change and just basically to the nearest 10. All right, let's do a bit of an easier one than that. I'm going to open up a new dude here. We're going to go select, let's just say 10 divided by 3. Right, again, used to be the world's most expensive calculator, but this is actually free. All right, so 3 doesn't go evenly into 10, right? I'm sure you remember your math. There's like an extra third popped off there. If you want the remainder of that, you can go mod. Actually, let me have a quick reminder. Mod 10 instead of divide, comma 3. And what that does, it returns the remainder, okay? What's 11 mod 3? Well, it's going to be the remainder of 2. What's 12 mod 3? Well, this will be an even division, so the mod is 0. Okay, so it returns the remainder. So sometimes this function is used for basic easy things like, shade every second line so it's a different color. Sometimes I've had to use this to validate barcodes, because there's a lot of barcodes and social insurance numbers up in Canada, because whereas the social security number here seems to be fairly easy to work out, in Canada, because it's a smaller population, it is one ginormous modulus calculation. So that's why they can scan it right away and they'll know whether it's made up or not. They won't know whether it's yours or not, but they can scan it, and if it doesn't, after this big calculation, spit out like a 0, they know that it's not right. So anyway, mod, that's what mod is, short for modulo, and here I guess they're taking so 16 doesn't go into 235 evenly, so showing that's the remainder, right, of it. Sure. All right, great. Absolute, thank God, remarkably easy. Absolute just takes negative and returns everything as positive. Everything that goes into an absolute function it'll always return a positive number. Sometimes, for example, we just want to know the difference between 2 dates, and we don't have to sit there and have to deal with putting the older date first and the later date second, and then maybe some later on the data, the newer date is first and the older date is second. We don't want to deal with, you just want to know how many days are between these 2 dates. That's what absolute does. It returns it in always positive. All right. That's all I'm going to show with numerical. There's a lot more numerical functions in that, by the way. All your trigonomic functions are here. There's some power functions, square root functions. There's a lot of different mathematical functions. I mean, it's a database, right? You can definitely do math. Now we're on to date functions. So date functions, one thing it's first of all showing you is that, hey, look, if you have 2 dates, the difference between 2 dates is a date. Let's have a quick look at that for a second. So I'm going to go sysdate. All right, so I'm going to go sysdate. Notice if I add something to a date, if I add a number to a date, it returns a date, right? We're now into tomorrow. When you take a date and subtract it from another date, that returns a number. So back over here, let's get rid of this one. And let's get rid of this L pad. Let's go back to a simpler time here. Where's my date? There's my date. So I want to know how long ago that was. So what I'm going to do is I'm going to go sysdate subtract or dot order date. Okay, I do that, and that's how many days are between the sysdate and the order date. Now, see how these the decimals are all like the same. Watch what happens when I run it right now. Right, they're all the same. I'm going to run it right now. Right, so this is telling us that it is very well aware of the time as well, right? It's returning the number of days and then a fraction of the time. Okay, so a couple things we'd be tempted to do with this is, first of all, as I said before, if I'm just comparing two dates and I don't care, I might want to throw the whole thing to an absolute, so I can do that. If I want to know how many days, I get the choice of rounding or truncating, and it really depends on my business logic for this. Normally, like when it comes to, for example, work anniversaries, you have to have a complete like day. You don't, we don't round up at noon the day before my year anniversary. I don't get rounded up. It only happens on that actual day. So I would be tempted to truncate this, is what I would do, because I just want to know the number of days and I don't want any kind of rounding nonsense. Cool. And so now that is the number of days old this particular order is. Also showing how old the data is. All right, so that's not a date function. That's just telling you how dates work. But what if you want to know how many months are between? Well, first of all, if you want to know how many weeks are between, that's pretty easy, right? If you took this thing, that's the number of days, you divided it by 7, now you've got yourself the number of weeks, right? So it's pretty easy. And I guess, by the way, probably moving that division into the trunk would have been the way to do that. So that's the how many weeks. Great. But what if you want to know how many months? All databases have a way to do this now, and it's basically months between. It may not look like months between, but it's basically you take a function like that, you put in the date, the two dates that you're comparing, and that would be the number of months between those two dates. And then obviously, well, we're here. So there's months between. I'm not going to bother, but you can do the whole truncate, and if you want years between, you just divide that by 12 and whatever, right? So, but that's an example of it, sort of a date function. Months between. There's that guy. So right there, he's asking the order date and the publisher date. Add months. I've already shown you how you can add days. You just add a number to a date. You get the date in the future. Add months is literally adding months to a date. And so there you go. They've added, for some reason, I guess, a year and a half onto a date. Next day is, when is the next Monday after a particular day? This is important for paychecks, right? You get paid usually on the, maybe every second Friday or something like that. So, that kind of, that's one of the reasons we can kind of use this. We can also use this. I've mostly just used it for basically Friday, trying to figure out when the Friday is. So anyway, so that's what next day is going to be for. And then a to-date function will take a string and convert it to a date if you give it the appropriate format. When you have a date that is already in that format, it's not a big deal. Like, so for example, 25 December 2023, right? So that is a string, but it actually looks very much like a date. The database is expecting it to be a date. So if I was to say, hey, to date, it should, I don't think it's going to have a problem converting this. I don't think, he says. Yeah, so that converted very nicely to a date. But if somebody had said, hey, Grant, I'm going to give you the date like this, the 12th month, 25th day, 2023, it's going to go, dude, I don't know what you're talking about. I can't understand that. So I have to give it an appropriate format string. And I think I'm going to show you these in a minute, but it's basically month slash DB YYYY. That is basically my conversion string, my format string. And now I'm back to basically showing a date again. Okay, so a to date takes a string and converts it to a date. It's a conversion function. There's another kind of conversion function. Yeah, I've already shown you the tochar. Tochar basically takes anything and tries to convert it to a character string, usually pretty easy there. And toNumber would take a string and convert that. I'll show you a bit better of one in a minute. Dots. There. And I blew it because why? toNumber takes that string 9 decimal. No. Oh, it is Grant. It's a dot. Thank you. Okay, I'm going to go back to the way it was before. I don't want to show you that yet. Okay, so it's that. I go. Yeah. You know it's numeric because it's right justified. You know this is, well, dates and characters are all left justified. So these guys here are conversion functions. Your head swimming, it's fine. We have character functions we just talked about where you had the conversions and then you had just some basic string manipulation functions, the substring, the in-string, the pads, the replaces, the trims. Then we did a little bit of numeric functions, which are basic like round and trunk and mod and absolute. Then we started a little bit with the date functions. We had months between, we had add months, we had just the concept of a date. We're about to, yeah, in a minute, I'll talk a little bit more about that. And when I showed you this example here with the, you know, why does that work? Why does that format string work? This guy here is actually a fairly valuable slide because it's showing you all the various ways. Like I used which is basically 2-digit month. I used DD, 2-digit year. I used YYYY, 4-digit year. When you're converting either from this format or to this format, you can use these formats to actually get some really neat values. So let's look at today's date again for a second. So I'm going to go sysdate, which is the function that returns today's date. Okay, we go. And now I want to control how that looks. Well, now it's not a toDate function, it's a tochar function. So I can go tochar, and this will now convert that date into a string. But now I'm going to control how it's going to convert to a string. So for example, I can go DD space month, comma, YYYY. So notice what it's going to do. We get 4th of April, 2023. I don't think any of you really want to deal with why there's so many spaces there. You know what, just to demonstrate that I can actually fix it, I'm going to do that. And now I lose my spaces, but I don't want to spend a lot of time on that particular idea. But what this does is it's going to basically control not just the full month, but the capitalization of the first letter. If I wanted this thing to be for some reason lowercase, I could put that thing in lowercase, and now the thing is in lowercase. So when you're looking at this slide here, this is actually showing you some really neat ways you can alter either the way the date looks like in the projection, or the way if you get your date in some goofy format like this, how you can basically get the date to be translated back to an actual date. Okay, so the next couple are the round and the trunk. So round and the trunk. So rounding a date, truncating a date. Rounds can be used for dates and numbers. Trunks can be used for dates and numbers. All right, so it's exactly what you think about. If you rounded a date, where's the round? Round is right there. So you're going to round it to the nearest month, round it to the nearest year. You can round it to the nearest quarter, which is definitely used quite a bit. Actually, I think, no, I think truncating is how you do the quarter. But either way, you can round to the nearest year, the nearest day, because remember, there's a whole time component trapped in there. You can round it to the nearest hour, minute, second. So, so it works just like math, right? So if it's afternoon and you round to the nearest day, it's going to round to the next day. Truncating, if it's afternoon, it won't care. It'll truncate the time, and you'll end up with the date. Higher dates, by the way, are usually truncated. Like, you know, if Caleb was hired like 1 minute after me, the HR system wouldn't give a crap, right? We were both hired on the same day, so that the time would be truncated. Sorry, you guys are staring at the top of my head. All right. Forgive me if I don't spend a lot of time on regular expressions, because, oh my God, this is just something you're going to want to have a beer or whatever and just sit and look at that and look it up. It's really, really, really cool. This is kind of saying that the first 3 characters have to be numeric. Then there has to be a dash. Then the next 3 characters have to be numeric. There has to be a dash. And the next 4 characters have to be numeric. And so what this is kind of doing is it's saying, show me the suppliers who have a phone number in their description. I hope you can appreciate how cool that actually is, because that would be very tough to do. In fact, I don't think it's even possible to do without using a regular expression. So it's a cool way. All these regular expressions are ways that you can intelligently look for patterns in the data, not just the data itself, right? So in this case, we're not looking for phone numbers. We're looking for things that look like phone numbers. And there's so much more to regular expressions. When I was doing, I did some work in AI and all that. That was kind of some, we were using regular expressions. All right. Regular expressions, by the way, don't just exist in databases, right? They exist in programming languages as well, and a lot of data intelligence. All right, we're going to do now the others, and then we're going to have a break. All right. And I'm okay if a lot of this stuff is kind of hitting your head and falling off, because this chapter is kind of like a reference chapter. However, when we go into the group functions, there's a lot less functions, but more theory. Okay, so I want to make sure you guys are fully ready for the group functions, because that, in my mind, is one of the most important things. And I think sometimes it's difficult to learn that on your own. I think these functions that you're getting here in this chapter, just like in Excel, just like in Access even, you can probably just Google stuff and figure it out pretty quickly. But when it comes to group functions, there's some basic knowledge you need to understand about how they work. And so I want to make sure that you're fresh for that. All right. Other functions, we got NVL, NVL2, the toChar, which is a conversion function. The two numbers also a conversion function, decode, and soundx. So, and actually is at least one other one I want to show you. So anyway, NVL. I think, was there, anyway, I'll just stick with this one. Here's the deal about NVL. Right. No, I don't like that. Well, whatever. So the ship date, in this example, if you just look in this column, ship date is null, right? So when I was talking to you guys about nulls before, I basically said, I use the analogy of money in my pocket, right? You don't know how much money is in my pocket. You give me $5, I put it in my pocket. You still don't know how much money is in my pocket. That's exactly what would happen if this was a null, right? If it was something like select money in Grant's pocket plus 5, and the money in Grant's pocket was null, then you wouldn't know. And so the result of that would come out as null. But what you could say is that the null value of the money in Grant's pocket is 0. It'd be basically NVL, money in Grant's pocket, comma 0. Now, all of a sudden, what you're saying to the database is if you don't know how much money is in Grant's pocket, assume 0, which, as I have 2 adult children living at home, is probably accurate. Assume 0 and then add 5 to it. Okay. So what's going on here is it's saying the null value of ship date is a particular date. So if you don't know what the value of ship date is, make it that date. And probably just a little bit more criticism on this particular query. If that's a date, stick a to date in front of it. That's what I would do. I put a to date there and I put a to date there. I'd also, by the way, use that string of DDMONYY, because the only reason this is working is that the default interpretation of a date in this database is DDMONYY. If you took this query and ran it on like another database, it might not work. And I'll tell you, like I've had that where, you know, someone took my query and ran it on a European database, and that's not their default format, and all of a sudden it wasn't working. But if you hard code the actual format in a to date, it's going to work every time. And then the other thing, of course, I'm mad at is the as. I've stopped talking about the as, but just because I've stopped talking about it doesn't mean that it hurts every time I don't see it. So that's the NVL. Okay, NVL. And it's used quite a bit. It's used quite a bit in searches, you know, like for example, actually let's do the example from the employee. So if I go select asterisk from HR.employees, okay. So one of the things I've done here in the past is if we wanted to basically somehow add these together, right? So this is actually, I think, supposed to be a percentage. It's a percentage of their salary. So if I basically said, hey, give me the employee ID, the last name, just because why not, salary, and the commission percent. Okay, if I do that, I go. Great. Now what I want is the total salary. Well, the total salary is the salary multiplied, what is my multiplied by 12. That's great. But if they're salespeople, they get a little bump. They get, like in this case, 30%. So what I'm going to do now is I'm going to basically take this, first of all, put it in parentheses because I want to indicate that's what I want there. Now I'm going to multiply it by, and remember 30%, if I want to increase it by 30%, it's going to be 1 plus the commission percent. Okay. So if the person made 10%, then what we're going to see is the yearly salary increased by 10%. Let's go. And what we'll see is almost everybody's null except the people that have a commission percent. So what we want to do now is we don't want to have commission percent. We want to be very careful with this possibilities for nulls and put in null value of commission percent, comma 0. All right, let me go. And now all of a sudden everybody's back to working again. And that's a very classic example of an NVL. Basically, if you don't know what the commission percent is, make it 0. That's kind of what that's about. NVL2, what NVL2 is doing, and yeah, I'm gonna have to do that. I'm gonna have to actually do the query for that. So let's go the NVL2. I like to call it the sequel. The NVL2 of commission percent. Now, sometimes if you don't know, just test it out, because I kind of get confused sometimes too about what this is actually going to do. This might not work, by the way, because that's numeric and these are characters. If it doesn't work, I'll try to fix it. Okay, good. So if this is null, show the second argument. Otherwise, show the first argument. Right? NVL2. If it's null, show the second one. Otherwise, show the first one. So actually, now the business logic behind this makes sense. If this is null, so if we don't have a shift date, then it hasn't shipped. Otherwise, we have a ship date, and that's what that's doing. Pretty cool. Null if basically just means null if they are equal. So here's our null if right there, our paid each and retail. If they're equal, make it null. Otherwise, show the first value. I've used that actually in a query that I can't explain yet, but soon I'll be able to explain it. But anyway, it does get used. And then there's the tochar, where in this case, I've kind of shown you this, but take a numerical value and convert it to a string with that format. And similar, by the way, to the dates, there's a whole bunch of different formats you can put in there. But I know that we don't want to talk too much more about them, but they're all there. Okay. All right. Last, I'm not going to talk. Yeah, I'm not getting, no. Dual I've already talked about, thank God, but I will talk about these two, the decode and the case. All right, let's talk about the decode and the case. And let's go back to our friend, the super long query here. I'm going to pull out that, and I'm just going to, yeah, that's good enough. Okay, go. Okay. So I've decided that computer books are going to get a 10% discount. nobody else is going to get a discount. Okay, so what I'm going to do is right after retail, we're going to add a column, which I'm going to call 0 at this point as discount. What we're doing is we're heading towards the idea of an if-then logic in your functions, an if-then logic in your functions. If this is computer, make this 10%, right? So how do we do that? One possibility, and this is gross, is to go decode. I can go decode category computer. If it's a computer, make it 0. Any guesses as to what we're going to see for fitness? If you don't know, it's because you don't know, and so you get no. But now the computer books get a discount. I said 0, by the way. I meant 10%, right? So let's go 0.1, right? So that's our discount. It's 10%. Cool. Now, everybody else gets 0. So how does that work? Well, what you can do is you can go comma 0. So if the category is computer, make it 10%, otherwise make it 0. And now what we're going to see is the value is going to be in every single one of these columns. This looks a little bit gross to the eye, so sometimes when we're typing this, we'll make it look like that, right? So it's a little bit more obvious as to what's going on. And now if it's fitness, they get 20%. Well, how do you get that? What I would do is I would add a few characters here and go fitness. Oh, case is important. I could use a case conversion function for that. 0.2 comma. Move that over a little bit. Boom. And there's your basic if then else logic. All right. And that's the decode. And that's what this slide's about. So if the state is in California, I guess 0.6, or the tax rate 6. If it's in Florida, it's 7. Otherwise, they get no tax. They get 0. So that's what that's about. But wait, before the break, again, I'm not totally ignoring these, but I'm going to ignore them for now. Before the break, this would be the better way to do this, but this is a horrible example. So let me go here. Decode is not ANSI standard, but what you can do is do the same thing and be ANSI standard and use a case. So I'm going to type this exact same thing in a case. I'd go case, and I'm actually going to do it slightly gross, but I'm going to go when the category is equal to computer, then 0.1 end. So I'll put a comma. So now we're kind of back to what it was like when the decode only had 3 arguments. If I want to have that catch-all at the end of that, I can go else 0. Now everyone's back to 0. Or I can say when category is equal to fitness, then 0.2. Oops. Yeah. Punctuation is important. And so now these two are now exactly the same. Okay. But this is definitely the preferred format, 9 through 15. And the reason it's preferred is because you can actually do a little bit cooler things. What if I want cooking to have the same discount as fitness? I can actually go, instead of equals, I can go in. I can say if the category is in fitness, and yeah, I somehow messed that up. There it is in fitness and cooking. So it's more flexible, right? Also, I can add inequalities. I can say if the category is not computer, right? I can do that kind of thing. And I can even say other things like if the price of the book is over a certain amount, they also get a discount, right? So I can basically say when the retail is greater than let's say 80, then the discount's 30%. Right, there you go, 30%. So the case is more flexible. It can deal with inequalities. And actually, that's an inequality. It can deal with, it's a lot easier to read as well. And it can actually look at different columns. This logic is possible to do in decode, but it'd be a lot harder to read. So that's why I'm telling you the case is the preferred. This separates you from the chaff. Don't use decode unless you have to. You should use case. All right. That was long. That was gross. Thank you for your attention on that one. Let's pick up at we'll say 7:15. And what we'll do is we'll go through the group functions. I'm going to turn my camera off and my microphone off, get myself some water, and get myself spiritually prepared for the next bit. If you got questions, by the way, text or chat, or say it, I should say. Yeah, we're totally not doing that. Not doing that. No, yeah. Yeah, I think. Oh, you didn't have a grant. Let's do that again. All right. All right. So our next little journey is going to be in the aggregate function realm, the group functions. This chapter goes, well, reasonably beyond where I want us to go. So I'm going to do what I think are the classics. And then I think I've decided that it will be next week where I'm going to talk about analytic functions. So we got a little bit of a break next week. We got subqueries and then the merge. So I think probably what I'll end up doing is finishing up the multi-row functions and then talking about the subqueries. And then at that point, we should be at a pretty even pace to finish out the material. We're actually pretty close, I think. Am I right? I think we're pretty close to the end days, aren't we here? So I have a look. So yeah, so see, we got 2 weeks there. So I'm thinking that basically I'll move some of the analytic functions here and subqueries, and then the week after we'll talk about the merge and views or whatever. Merge, I could go either way with that one. And then after that is our next sort of trigger, and then we're at the point of your projects and the grand finale. So anyway, all right, so let's go and talk about group functions. And I tell you what I would like to do with this is go more example based. So I'm going to do the classic select asterisks from employees again. Okay, it's a good one. It's a good one to basically screw around with. All right, so again, what is a single row function? Well, as you saw here, this init cap happens on every single row, right? But it returns one result per row. I'm going to ask this database to tell me how many rows are in this table in SQL, because I've just done this now using the IDE, but that's not necessarily how you're going to do this. So there's a multi-row or aggregate function called count. And I can say count up the number of salaries. And it's telling me there's 107 salaries. Count up the number of employee IDs. Remember, that's the primary key. So there's 107 of those. You'd expect there to be 107 of those if there's 107 rows. If you want to know how many rows there are, asterisks. basically count up how many rows are there. What happened there? That's right. I tried to run asterisks and it basically freaked on me. But anyway, so what's going on here? Here's a little bit of Zen for you. All right. It used to be that this query would run slightly slower than this query. This is an interesting one. Count how many ones are there. Well, remember, a literal like one happens every single row. So this used to be the way we used to trick the database to basically just telling us how many rows there were. Remember that we have this also in that fabulous user tables. I'm not going to finish it, but the user tables query, right? That also says how many rows there were too. But anyway, forget that. Only losers do that now. You basically want the asterisks. This is the classic. This gets run about 10 billion times a day across the globe as people are trying to figure out how big is my table? How big is my table? So count asterisks. And this is a great example of what multi-row functions do. I only get one row back. With the init cap, I got as many calculations, as many rows returned as there were rows. In this case, it went through all 107 rows and it returned one result back. That's why it's a multi-row function. This is an aggregate function. It's going to aggregate, basically just brings together. So there are a bunch of different aggregates that you should know about. Salary, for example. So salary, this is an individual column. There is one salary for every single, Grant, I guess you need to have your employees. Let's just throw that out. I'm going to keep this tab just for your basic look at the data, okay? So anyway, salaries, there's one salary for every single row, right? So if I said, hey, count up all the rows and give me a salary, it's going to get mad. It's going to say, dude, I got an aggregate here. You want me to add up all the rows. I can't just deal with a simple or a scalar value. But what I can do is I can say, hey, you know what? Can you add up all those rows? And it does, right? One value back for all the rows. Now, when it comes to numeric things like that, you would also have max. You have min. You have average. Thinking I may have messed that up. I did. I think it's oh my goodness. Not AVE. No, it's not AVE. Is it AVG? Average. Why am I losing my mind? There it is. I'm losing my mind. Okay, average. All right, so it's the maximum salary, the largest one, the smallest one, the average one. Of course, you get a ton of change. You are now smart enough to know how to deal with that by using rounds in this case, or maybe trunks. If you like your super duper math, you also have the standard deviation of salary. You also have the variance of salary. If you don't know what those are, then you don't need to know what those are. But if you do have any kind of statistical background, that's kind of interesting. And actually, by the way, this is telling me there's a wide variety of a wide range in salaries, as there obviously are, right? So anyway, but don't worry about it. If standard deviation variance didn't work for you, don't worry about it. This means that you either haven't taken a statistics class or it's been a long time. All right, so that is some basic numeric stuff. By the way, max and min also work on character data as well. So if I was to go, what's the maximum last name? It's going to give me the last name with starting with the largest character. Remember, each one of these characters have an ASCII value. And so Z, or Z as I prefer to call it, has got a higher value than A. Okay, so that's the max. So you might suspect then that min would give me someone beginning maybe with A, but something that's not Z probably. So let's have a look, and yes, there's able, right? So max and min work on other things besides numerical data. All right, that's exciting. Let's go back now and look at this a little bit closer. So what I want to know is what is the maximum, what is the total salary expense by department? Okay, so by department, that's what I want. So we're going to start changing this around a little bit. I want to have the salary expense we've already seen is going to be actually tell you what, let's do, yeah. So salary with all these queries always start with knowing what you're looking at. That's my data. Now I want to have the maximum amount, or not maximum, the total amount. So this is the total amount of my entire organization. But now I wanted to have broken it up by department. And it blows chunks. It blows chunks for the similar reason that I demonstrated this last time. It's basically saying, look, dude, you want me to add up all the salaries, but what am I supposed to do with this? It's not a group function. So one thing I could do is make it a group function, right? But this is not really answering the question I want to ask. So let's get back to this. How in the world would I group all my data by department, by department ID? How would I do that? Well, the good news is that we have 2 more clauses, and then you're nearly done understanding all the intricacies of SQL. And it is group by department ID. Once I do this, it's all grouped. By the way, let's add a little bit of nicety here. Order by department ID too, because why not? And so now what we get is a pretty neat report. Now I think Query Builder show this. Yeah, you guys saw something like this in Access as well, right? I still think honestly you're better off, in my mind, just basically struggling with the SQL. But if you do get stuck, get a query that's working and then try to, like if you want, try to build it in here and then go back out. I'll tell you, this was always one of the, for me, as a guy that had to learn SQL on his own, pre-Google, with nothing but other people's SQL to look at, this was one of the hardest things for me, was understanding, well, what exactly is line 3 doing? So line 3, and I think I got a little image for this. Right? Life of a query, life of a query. All right. Yeah. So just looking at this first bit, or actually, okay, this is better. All right. So and don't worry about the halving or anything at this point yet. That's the second clause that's coming up. But for some reason, we're trying to count the number of cities, some balance. What I want you to understand is that the from clause is getting you all the rows. Where clause does restrictions, but the group by then produces little groups. So in my memory here, what would I'd likely have is basically this is what the group by is retrieving, and then the select is just showing me what it wants to show me. So here's another common thing that people kind of mess up all the time. So I think you guys can handle this. Let me do one more quick thing to this query before I go on. Job ID was another one of those scalar things. I want to basically have it grouped by department and then the jobs in those departments. And I think some departments have multiple jobs. Yeah, 30 does. Okay, so I stick in job ID, all of a sudden the query stops working. Well, definitely doesn't work now, but it stops working because it's not a group by. So if I just basically put job ID in the group by clause, we're back to working again, right? What's going on? As soon as you put an aggregate function in your select clause, you have to group by anything that is not an aggregate function, right? Do you understand that? So as soon as you put something in the select clause that's not an aggregate function, you must group by it, or it just has no idea what to do with the data and it blows up with the not a group function or some other error. All right. So please keep that in mind, because that'll make your lives a little bit easier. Notice I don't have to actually show it. See that? I mean, I can have these 2 rows and not actually show the job ID, because remember, the select clause is just simply showing, it's presenting or projecting, I should say, the data that's available, right? So I'm choosing for whatever reason not to show the job ID. but obviously not a great practice, but sometimes there's reasons for that. All right, so we're back to this. Let me show you another problem. I'm going to basically say I'm only interested where the total department expense is greater than, or how about, yeah, less than, where it's less than 10,000. So a natural thing for any young new developer to do is to go where the sum of the salary is less than 10,000. That would be a very natural thing to do, and it's not going to work. And it's not going to work, back to my image, because what happens is that the where clause fires off before the group by clause. So the where clause fires off before the group by clause. Because of that, the where clause is firing off before we even know what the sum of salary is, right? The sum of salary is worked out right here. So there's got to be a way around that, and there is. There's another clause, and that clause is having. Missing the parentheses. Why am I missing parentheses? What are you doing to me? Having, group by that, missing whatever. Come on. Oh. Well, trust me, it still wouldn't have worked. But anyway, let's do that. Right, we're good? All right. So anyway, the having clause, it's like a second restriction. So in this picture, where I'm trying to basically grab only the balances greater than or equal to 60,000. If that was a where clause, we wouldn't know what the balances were because the sum of the balances aren't calculated till after. So the way this runs, we get the from client, that basically pulls the information. Where clause does any restrictions. The group by then makes their groups. The having clause is a second restriction, restricting only the groups, I should say, and then you actually get the results. There's nothing saying I can't have a where clause. I can go, for example, where the salary is greater than 0, like a single salary is greater than a single value. There's no problem there, right? But the aggregation, if I was going to restrict on an aggregation, that has to be in the having clause. And so now what you've got is you've got the sum total of all the clauses that we've kind of talked about. There's a select clause showing you what you want to see. From clause is where is the information coming from. Where clause are individual rows that are restricted. Group by basically groups the rows by some group. And if you leave the group by out, it treats the entire table as a group. Having then restricts on those groups. And then at the very end, it gets sorted. That's one of the reasons why you probably didn't catch it. But when I had that little comment there, that's my own little way to remind myself that all this happens and then it's sorted, right? So I hope out of this whole course, one of the things you're getting is that a SQL statement is, it looks like it's, one statement, but it's a statement comprised of clauses, and all this affects the programs that are kind of run and the processing that happens in the background, right? The processing that happens in the background. So I think with that, there's my select clause, the from clause, the where, and the group by. They're going to talk about sum, average, count. Oh, I didn't talk about the nulls. I suppose I should do that. Let's do that for a second, because that's a fairly easy one to talk about. If I go select the count, this is an easy one to do. Count employee ID, right? How many employee IDs are there in the HR.employees table? Right, so how many employee IDs? Well, there, there's 107, right? So how many salaries are there? And we know that everyone's got a salary, so it's 107. How many commission percentages are there? Well, not everyone's got a commission percent, right? So only 35 commission percents. So when it comes to these aggregate functions, they ignore null values, and that's typically what you want. If it was important to you that commission percents, if you wanted to put the business logic in there that they were 0, if they're null, that's where the NVL comes in, right? So that's what they're trying to say with this, with the count ignoring null values. That's kind of what they're saying here. Now they're using a where clause with the is null, but there you go. So I'll talk, actually, this one's important to me, but before I do that, there's the max, there's the min, and then data type. So count, max, min can be used on pretty well character, numerical, and date. Otherwise, so other functions like sum, for example, you can't sum up a bunch of characters, and you certainly can't sum up dates. I have no idea what that would look like. Then they talked a little bit about grouping, and there's your group by, right? Why do you need a group by? Because there's an average here. So you got an aggregate function. So you need to, if you're going to put category in here, you're going to have to group it by category. And so they do say it's a common error, but it's an error that I struggled with for quite a bit in a fairly hostile environment. So now you won't have to deal with that. Then how do you restrict afterwards? Well, that's the having, right? Having. You can't go where the average retail cost is, because now you know the where happens before the group. So you have to basically, if you need a restriction on an aggregate, it has to be having. So there you go. So where, restricts, group, and having. So that's not a bad little example. The only thing I did different is I had a nice order by at the end. All right, so what are we doing in this nesting? Because maybe I can get away with this. Oh. All right, you know what? Why not? Why not? Let's do that one for a second. So let me, I think I can, oh, I can't. Boy, they used images on this one. Drives me crazy. Give me a second here to quickly type that up where you're not seeing me type. So I'm going to go select, and this is using quantity and paid each from the orders table. And it's not the orders, it's JLDB orders. And we're going to join on the order items using, and I should put the JLDB. You can tell I'm getting tired because I'm not caring about case anymore. Using, well, that gets me aliases too. Geez Louise. Okay, I think I'm going to move this up now. Yeah, I'm going to move this back up. So using, oh, using, I don't like that one either. Okay, you know what? Let me type this the way I like it, which is going to be O and OI, even though I told you guys don't use single letters. Do as I say, not as I do. I'm going to go on O dot order, and is it what's it? Order number is equal to OI dot order number. Okay, so what all I did here is just grab the root of the query. Okay, and that's that. All right, so the next thing they're trying to do here is they're trying to go basically sum of quantity asterisk paid each. Okay, so if I went, they're together, they're multiplied. Okay, so first of all, let's multiply you guys together. Let's get that done. So there's our multiply. So we know that basically each line in the orders table is producing that, but we don't really have an order ID or order number. So we now know that each order, oh yeah, you're right. You are right. It's ambiguous. Okay, so each order number, like right there, there's an order with 2 lines. Cool beans. So our next step was to basically add them all up by order. Okay, so I'm going to go the sum of this. Now, as soon as I go sum, it's going to freak out because I've got a scalar value and an aggregate value. So I need to add that concept of grouping now. So I need to go group by the O dot order number. And what we're going to see is probably no change to row 1. Row 2 and 3 will be collapsed into one row. Row 4 will be one row. Row 5, 6, and 7 will be collapsed into one row. Okay, with the larger numbers. Cool. So that is the base query that this example is based on. But what they're asking for is what is the average order total. So what's the average order total? So what I can do now is I can say, hey, I'd like to have the average of all these. I know I spelled that wrong, but the average of all these numbers. And so what I'm getting now is the average order total, and it's not that again. Why do I keep doing that? It's G. It's a problem when you work in not too many languages is what I meant. So there's the average. Okay, so apparently in my entire order and order items, the average was about 80 bucks. All right, so that's an example of nesting. Now, another common nesting is if I want to go, let's go salary. Actually, let's go job IDs. All right, so now if I want to know, these are all the job IDs, but I want to know how many job IDs are there. This was that slide from a while ago that I quickly blasted through. This is how many job IDs there are, but it's kind of hiding the fact that some people, like, the jobs aren't all unique. You already kind of know how to get a list of the unique jobs, and that is distinct. So this would give me a list of the unique jobs, right? And now if I want to count those up, this is sort of another example of nesting. So the distinct clause gives me a list of distinct job IDs, and now I can count those. And so out of my 107 employees, there are 19 unique jobs. And that was that slide from way back up. All right. And as I said, with these guys, standard deviation and variance, don't worry about that. You may have to worry about that for your assignment, but don't worry about that in real life, unless you happen to be dealing with statistics. All right. So that's it for as far as I'm going to go with this stuff today, especially online in this soulless environment. So what I'm going to do is, let's just talk a little bit about what you are expected to be doing. And actually, we'll just do this straight in the assignment area. So I know that what you're going to see is the single row, and the single row is due on the 11th. The group functions is due on the 18th. So you got a little bit of time going on there. And remember that the ERD is also, just the DDL is also due on the 11th. All right. So so that's kind of what's expected of you over the next week or two. I will stick around if anyone's got any questions, but at this point, I'm now finished the more official part of the stuff. So you guys have a good week if I don't talk to you, and we'll see about, again, I might do this. Well, I probably will do the Zoom option for the next couple of weeks. I just understand a piece of me dies when I do that. All right, good deal. Thank you. See you guys next week.
Bye.
Bye. Okay, and Deshaun, I'm about to upload it now. If you're still hanging out there, I'm just about to do the upload now. I unzipped it for the, what's the word I'm looking for? I unzipped it during the break. That's what I'm trying to say. So let's go to content. I know you can't see what I'm doing. You probably don't care. You're maybe not even there, but I'm going to check it out anyway. I'm going to go to class kickoff. And I'm going to go and grab that zip file and throw it up there. So let's go this, and there's a zip. I'm going to move it up. All right. So
yeah, thank you for doing that.
Yeah. So it's 1% there, 2%. I got to do an errand. I suspect within an hour or two, you should see it there.
Sounds good.
There being, I'm sorry, where is there? There is in the, I put it in the class kickoff section. It's at the very bottom of that. Okay.
Thank you.
You're welcome. Talk to you later, man.
Yep.
Bye-bye.